Alright, welcome to the, I think, 8th video in this segment, and we're getting close to finishing all of the derivative rules. In this video, we're going to prove, then go into examples of the quotient rule, and then in the next video, we're going to go over exponent rule, and I think that's all of them. Then we'll start looking at graphs, and then we'll do some example problems from AP exams. Then we might go into integrals unless I'm forgetting something. And then some theories, but yeah, curriculum goes pretty fast in this class. So let's get right into it. So the quotient rule is, we've gone over a product rule where if we have f of x times g of x, then it's just f prime times g plus g prime times f. But what if this was to the negative 1 power? What if g of x was below? Well, if that's the case, then we use the quotient rule, which in our proof we'll just see it's a kind of a different form of the power rule. And also, out of all of the rules, this is probably the least important, because there's so many times where I don't know, say you have sine of x over x squared. You can use quotient rule here, this can be g of x, this can be f of x, but it's just a lot easier if we just move this to the exponent, so x to the negative 2, and then we do product rule. But we need to learn it nevertheless, and it's always good to see where this stuff comes from. So let's get right into it. Well, first, let's clear this out. And well, first, what this rule is saying is, if you have two functions of x divided by each other, then your result is going to be f prime times g minus g prime times f, all over g squared. So you can see this is a lot more than product rule, which is why I hate it. But just keep in mind that f and g are functions of f. We're just going to write f and g to make things a little easier. But let's get into the proof. Well, first, we're just going to prove this with product rule, because we like product rule. So first, f of x times g of x to the negative 1. We just move this into the top. And then, instead of divided by, we have times. And I'll write down the rule for product rule down here. F times g is just f prime times g plus g prime times f. We did that, we proved that in 2 videos ago, and we did some examples last video. But this, if we're finding the derivative, we can just do product rule. So f prime times g, well, that's just going to be f prime of x times g, and g is just to the negative 1 power, because it would be in the denominator, plus g prime times f. Well, if we take the derivative of g prime, derivative of g of x to the negative 1 power, well, we can do the power rule, where we bring that out in front and we subtract by 1. So let's do that. Negative 1 times g of x to the negative 2. But it's a little bit of a sneaky chain rule here, because g of x is a function of x, but we don't know what that function is. That function could be just regular x, and then the derivative of it is just 1, and then we don't really care about the chain rule, it doesn't change anything. But it could be x cubed or something. So we do need to take into account the chain rule and also multiply by the derivative of the inside. So you can think of this as like a power on the outside with a function inside. Hopefully that makes sense. And all of that is just this g prime part. So we can't forget about our regular f of x. So then it's times f of x. So let's move on. So we got negative g of x to the negative 2 times g prime of x times f of x. Now let me clear this out. So basically we just found the quotient rule by using product rule, which is why product rule is so much better. But it's not quite in a great form. So we're going to do some algebra and manipulate this equation a little. Well, first, let's see. I see f prime of x in the top, and this is to the negative 1, so we'll do g of x in the bottom. And then, don't forget this minus sign right here, minus, I see negative 2, so it's in the bottom, g of x squared, and then g prime of x times f of x. F of x times g prime of x. And we are almost here, but what we can do is multiply this by 1. You might see where I'm going with this. We're going to multiply each side by the top and bottom by g of x, and anything divided by itself is just 1. Anything multiplied by 1 doesn't change anything, so we can do that. So we will end up getting all of this together. We will get f prime of x times g of x over g of x squared minus f of x times g prime of x over g of x squared. And with this, it's a common denominator. That's why we multiplied by g of x to get a common denominator. And when you have that, you can just combine the fractions. So I'll just erase this real quick. Make this a little neater. So instead of like two separate fractions, we can just have one big one and have this subtract sign. So this is the same as this. So let me just go over it one more time real quick and then we'll do an example. So moving this over, it is f prime of x times g of x minus f of x times g prime of x all over g of x squared. And that is the derivative of f of x over g of x. No matter like how much room I try to clear out, I always run out of room. I don't know. Gotta think of a solution. I just need to be more organized. Let's do an example now. So let's say we want to find the, we'll box this off. We want to find the derivative of, let's say, x squared over sine of 3x. And we'll do 2x squared, because why not? Well, with this, it's really just like you say the numerators f of x, denominators g of x, or vice versa, and then you just follow the formula that we found. So let's just write out our stuff. F of x, g of x, f prime of x, g prime of x. And then we'll just plug them in. So f of x is just 2x squared. Remember, numerator, denominator. And sine of 3x is g of x. And then we'll just find the derivatives of these. We get 4x, the power rule. And then this is just 3 times cosine of 3x. Derivative of sine of x is just cosine of x, and we have 3x, so there's a little bit of a chain rule. And now we just plug this stuff in. I hate this rule so much. I'm just trying to get through this video. So f prime of x, 4x, times g of x, which is just sine of 3x, minus f of x, which is 2x squared, times g prime of x, which is 3 cosine of 3x, all over g of x squared. So 3 cosine of 3x squared. So let's simplify this. We get 4x sine of 3x minus 3 times 2, so 6x squared cosine of 3x, and then we square the 3 and we square the cosine. Can't forget about its like a FOIL thing. So we get 9 cosine squared 3x. And that's our answer. That's our derivative. It's pretty ugly. There might be some way to simplify it a little more with some trig identities. Maybe you can factor out a 2x on top, but I don't know, that's pretty much all you need to do.